Hey everybody, today we are going to actually take a step back and we're going to review section 8.1. Now I taught you section 8.1 way before the shutdown even, so you're probably asking why the heck are we going back and doing this? Well, at the end of this week or maybe even early next week, I'm not really sure, we are going to go over section 8.5 and it directly relates to 8.1, being that it's been probably 5 or 6 weeks since I taught you 8.1, I figured, hey, we could probably use a refresher on it. So we're going to take a day to do that now. First of all, a review from chapter 7. Cosine is the x value. So if we're talking on kind of an xy scale, the x value is positive in quadrant 1, because you go right. It's negative in quadrant 2, negative in quadrant 3, and positive in quadrant 4. Now, along the same lines, cosine is the same as, grab the right pen here, cosine is the same as 1 over the secant of theta. So these are the same thing. Positive in quadrant 1 and 4, and negative in quadrant 2 and 3. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, sine. Now again, sine is the same as 1 over the cosecant of theta. And remember, sine is positive above the x-axis because it is the y value. So it's positive here and here. Y would be negative here and here. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, tangent is y over x. So we got to think, well, where is tangent going to be positive and negative? Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Well, we get a positive number when we have, so a positive number is when we divide a positive by a positive or a negative by a negative. So in other words, what quadrant is both y positive and x positive? Well, that would be quadrant 1. And when is it negative, negative? When do we go left and down? Well, if we go left and down, that would be quadrant 3. So tangent is positive in quadrants 1 and 3 and is negative in quadrants 2 and 4. Okay. Now we need 2 quadrants for each interval, and to do this, we can use our unit circle or reference angle. And again, a reference angle is simply the shortest path to the x-axis. For example, if you have an, let's say a 120 degree angle, 120 would be, well, this is 90, so 120 is right there. That's a 120 degree angle. Now, the reference angle for 120 is not 120. It's how do you get, what's the shortest path to the x-axis? Well, that would be 60. So the reference angle of 120 is 60 because it's the shortest path to get back to the x-axis. Now, hopefully that should all be a review for you. Okay, next up, it says these are the example problems. Now, these are also the same ones from your 8.1 notes. So if you have your 8.1 notes, you can kind of follow along. I would recommend redoing them, though, because like I said, it has been 5-6 weeks since you've looked at them. So it might just be beneficial to go through these problems again. Okay, the next thing it says is use a calculator from the link. So I've posted a link to a scientific calculator. Use that one. It's really easy to switch between degree and radians. The one on your phone, you're not able to do that. I've messed around with probably 6 or 7 different online calculators, and this is by far the easiest one to use. So I would just use the one that I am about to post, or that I will post with this. That's what I'm going to be referencing. So yeah, just use that one. Okay, so it says solve for 0 degrees is between, theta is between 0 and 360 degrees. So that should tell us that our mode of our calculator should be in degrees. So if we're dealing with sine, and sine is positive, we're looking for the positive because 1/2 is positive. Well, where is sine positive? It's positive here. I picked the right color. Sine is positive here and here. It's negative here and here. So in other words, I don't care about this quadrant and I don't care about this quadrant because sine, my y values, are negative in quadrants 3 and 4. I only care about quadrants 1 and quadrants 2. Okay, two different ways to do this. Okay, first thing we can do is use our unit circle. This is asking, where is sine equal to 1/2? And if you look at your unit circle or whatever else, you should know that sine equals 1/2 at 30 degrees. That would be right here. So what's the reference angle right there? The reference angle is 30 degrees because that's the shortest path back to the x-axis. Now, to find the other kind of answer, I guess, the other answer to this, sorry, I kind of stumbled there. So to find the other answer to this, what we need to do is we need to go back 30 degrees. Our reference angle here is 30 degrees. Now, since this is 180 and I am going back, I would have to do 180 minus 30 is 150. Now, if you look at your unit circle, you can say, well, yeah, Mr. Adler, duh, I knew. I can just look at it, and the y value at 150 is 1/2, so my two answers are 30 degrees and 150 degrees. I could have known that just by looking at my unit circle. Well, yeah, but it's not always going to be like that. So you need to be able to understand how to use this reference angle, how to say, okay, well, there's my reference angle. I said I had to move back 30 degrees, and 180 minus 30 gave me 150. Okay. Now, on to the next one. So now, we are looking for the cotangent of theta is -1. Okay, well, first of all, where is cotangent negative? Well, cotangent is negative in this quadrant and this quadrant. That means I don't give a you-know-what about quadrant 1 or quadrant 3. Why don't I care about those? Because in quadrant 1 and quadrant 3, cotangent is positive. And I only want a negative answer right now. Another trick that I taught you guys that you might remember or may or may not remember, is the all students take calculus. In quadrant 1, everything's positive. All the trig functions are positive. In quadrant 2, sine is positive. In quadrant 3, tangent is positive. In quadrant 4, cosine is positive. That's just a little, I think they're called mnemonic devices, to remember what quadrant each trig function is positive in. Okay, so I want to figure out where is cotangent equal to -1. Well, first, the question you got to ask yourself is, how do you get a fraction to equal -1? And why am I saying a fraction? Well, remember, what is cotangent equal to? Cotangent equals cosine over sine, which is x over y. So if you had an x over a y, when would you get a -1? Give me an example of a fraction that would give you -1. Well, an example would be like 7 and -7, or -6 and -6. Both of those would give you a -1. So in other words, I am looking for a fraction that looking for an x and y where I have the same number with opposite sign. So if you look on your unit circle, you should look and see, well, at 135 degrees right there, we have my x is -√2/2, and my y is √2/2. This is at 135 degrees. Now, like I said, you can look at your unit circle to figure out what this one is, but it's a good practice to figure it out using reference angles. So, again, this is 180. How do you get from 180 to 135? Well, you need to subtract 45. So that means your reference angle is 45 degrees. Okay, so what is this angle right here going to be? Well, this is 360. I'm going down from it, so 360 minus 45 should give us 315. This angle is 315. So your two answers now are 135 and 315. Okay, those were easier because we could use our unit circle to figure them out. Now, in this next one, we're going to need a calculator to figure it out. So the first thing we need to do, if you notice in number 2, my trig function was by itself. In number 3, my trig function was by itself. Excuse me, in number 1, it was by itself. In number 3, my trig function ain't by itself. So what I need to do here is get that trig function by itself. So just treat it like if it was 3x plus 6 equals 5. So just treat this like it's an x. I got to get cosine by itself. How do I do that? Well, first I need to minus 6. 3 times cosine of theta equals -1. Now, divide by 3. I get cosine of theta equals -1/3. Okay, so what does that tell me? Well, first of all, it tells me my cosine is by myself, and it is negative. So where is the cosine negative? Where are my x values negative? Well, I know for a fact cosine is not positive in quadrant 1. Excuse me, cosine is not negative in quadrant 1. It is also... Oh my God, Mindy, shut up. No, sorry, people. Oh my gosh. Yes, I see the lady. God. Okay. Sorry about that. It is also negative, or not is positive in quadrant 4, which means it's not negative. So I only care about these two quadrants, quadrant 2 and quadrant 3 right now. Okay, so how do I figure out when is my cosine -1/3? That's not on my unit circle. Well, now we need to use our calculator. Again, pick up that link that I dropped in Google Classroom, and we got to get theta by itself. So how do we get rid of a cosine? Well, you got to take the inverse cosine of both sides. These cancel, and you get theta equals the inverse cosine of -1/3. So on that calculator, hit the cosine -1 button. Again, it should say arc cosine on your screen when you hit that. That's okay. Then type in -1 divided by 3, close your parenthesis, and you should get theta equals 109.47. I'm going to call it 109.5. That's correct. Okay. Now we got to do a little bit of thinking. So where is 109.5? Well, this is 90 degrees right here. So 109.5 is going to go somewhere past, right? But now I got to figure out what my reference angle is. So in other words, how do I get from, again, this is 109.5. How do I get from 180 back to 109.5? Well, what is 180 minus 109.5? We should get 70.5. That means my reference angle, this bad boy right here, is 70.5. So what that tells me is I have an answer in quadrant 2. I also have an answer in quadrant 3. So what's my reference angle here? Well, this is 180. Now instead of going backwards, now I'm going, what color should I use? I'll use blue. Now I'm going forwards 70.5. So I'm going to do 180 plus my 70.5 to figure out what my other terminal angle is. So I get 180 plus 70.5, and I get 250.5. Your two answers should be 109.5. Where did I write that before? 109.5 is one of them, and 250.5. Those are your two answers for theta. Okay, one more problem today. The only difference here is now it says solve for theta is between 0 and 2 pi. That tells us that we need to be in radians. Now, I realize I made a mistake here. You're going to see this a lot. Some books use theta, or references books, whatever you want to call it. Some use theta, some use x. Some use x for radians. Some use theta for degrees, so on and so forth. So this x should really be a theta. Just keep everything in terms of theta. That's the easiest way to do it. Okay, so now we need to realize that we have secant right now. We're not really comfortable working with secant. So secant, why don't we rewrite that as 1 over cosine of theta equals 2.5. Now, this looks goofy because I have a fraction and it equals a whole number. So why don't I put this over 1, cross multiply, and then get my theta by itself. So I'm going to say, well, 2.5 times cosine of theta equals 1 times 1 is 1. Now I want to get cosine of theta by itself. So I'm going to divide both sides. I don't know why I put that in red. That's kind of bugging me. Now I want to divide both sides by 2.5. Divide by 2.5. And you should get cosine of theta equals 1 over 2.5. And again, we are in degrees, right? Or excuse me, we are in radians right now. But at the same time, that doesn't necessarily matter when I'm talking about what quadrants I want to be dealing with, because I only care about positive and negative. 1 divided by 2.5, that's a positive number. Excuse me. So where is cosine positive? It's positive in quadrant 1. It's not positive in quadrant 2. Again, I'm talking about the x values. If I go left, I'm not positive. That means it's not positive in quadrant 3, but it is positive in quadrant 4. So I care about this quadrant and this quadrant, quadrant 1 and quadrant 4, because cosine is positive in those quadrants. Okay, now again, we got to get theta by itself. So in order to do that, I need to take the inverse cosine. That's a highlighter. I need to take the inverse cosine of both sides. Okay, when I do that, I get theta equals the inverse cosine of 1 over 2.5. Key here is we got to make sure we are in radians mode. Okay, so to clear everything out, you hit the AC button on the bottom of your calculator. It's on the bottom row right in the middle. Hit AC. Make sure you're in radians. You're going to hit the inverse cosine button. You're going to hit 1. You're going to hit the divided by button. And then you're going to hit 2.5. When you do that, you get 1.159. I'm going to call it theta equals 1.16. So now we got to do a little bit of thinking here. Okay, well, I know that if I'm in radians, this is 0. If I'm going around the circle, this is pi. Pi is really 3.14. 3.14. So what is this? Oh boy, that's not what I tried to do. So what is this point at the top? What's that point? Well, it's pi over 2. So what is pi 3.14 divided by 2? That point is 1.57. So where does 1.16 fall? I don't know, maybe here? Is that 1.16? Works for me. Okay, now if I go around the circle, I'm going around, I'm going around, I'm going around. This is 0. It's also 2 pi, which is 6.28. So I just figured out, hey, my reference angle right here is 1.16. So I can also go down whatever my reference angle is, which is 1.16. So what is 2 pi, or 6.28 minus 1.16? Well, type in your calculator, you would get 5.12. Your two answers here are 1.16 and 5.12. Okay, I hope this kind of jogs your memory. Please, again, use the calculator I kind of supplied you with. I think it's the easiest one to use. If you have one like we have at school, go ahead and use that. Otherwise, yeah, use the one I gave you. I will post in a